Welcome to clickmyproject.com. Now let me see about the process lossy compression and iterative reconstruction for encrypted image. Let me discuss about the process lossy compression and iterative reconstruction for encrypted images. Initially, the image that has to be sent by the sender is encrypted using pseudo-random permutation. The pseudo-random permutation encrypts the image based on the key value generated by the sender. The same key is used for decryption by the receiver. The encrypted image is then compressed. The compression is done by converting the pixels into a series of coefficients using a discrete cosine transform. This then exclusively rough and fine information in the coefficients were removed. Now some amount of data in the image is reduced. That is, the clarity of the image is lost during this compression process. So the image will be distorted. Now this distorted image is then sent to the receiver. The receiver first decomposes the image and the gray values of the rigid pixels obtained using the inverse discrete cosine transform. Then the decompressed image is then decrypted by using the same key generated by the user, which is used for the encryption process. This process is done so that the final image is reconstructed. This algorithm is more suitable for low bandwidth channel transfer. The resulting image PSNR value is high so that the image is well enhanced. Now let me see the flow of the project lossy compression and iterative reconstruction for encrypted images. Initially, the image that is to be processed is first pre-processed. Pre-processing removes the unwanted noises in the image. Pre-processing is the basic operation in all image processing tasks. For in this paper, we are using Gaussian filter for pre-processing. The Gaussian filter smooths the images by passing them into a Gaussian, which is a low filter that removes the unwanted pixels from them. Then the pre-processed image is encrypted. This technique involves three different phases. The first phase in the image encryption is that the image is split into blocks and the blocks are permutated. Further permutation is applied based on random number to strengthen the encryption. The second phase is the key generation phase, where the values used in the encryption process are used to build a key. The third phase is the identification process, which involves the numbering of the shards that are generated from the secret image. These shards and the key are then transferred to the receiver. The receiver takes the help of the key to construct the secret image in the decryption process. This technique is proposed a unique one from the others in a way that the key is generated with valid information about the values used in the encryption process. The same key that is used for encryption is used while decryption process. Then the encrypted image is compressed. Here lossy compression is proposed. That is, there will be losses in the image. That is, there will be distortions in the image after compression. For compression, we are using DCT algorithm. The original image is divided into blocks of 8x8. Pixel values of the black and white images ranges from 0 to 255, but DCT is designed to work on the pixel values ranging from -128 to 127. Therefore, each block is modified to work in the range. DCT matrix is calculated. DCT is applied to each block by multiplying the modified block with DCT matrix on the left and the transpose of the DCT matrix on the right. Each block is then compressed using quantization process. The quantized matrix is then entropy encoded. The compressed image is reconstructed using the same reverse process. Now the image is transmitted to the receiver. Initially, the receiver decompress the image and then decrypt the image in order to get the original image from the original image that is sent by the receiver. Finally, the performance analysis is done by calculating the PSNR, compression ratio, and bits per pixel values. The PSNR ratio is an approximation to human perception of reconstruction quality. It is calculated based on mean square error. PSNR value is high for enhanced images. Thus, the input image that is sent by the sender is compressed and then is first encrypted and then compressed, and it is sent to the receiver, and the receiver decompresses and decrypts and gets the original image using the same key that is used for the. Now let me see the execution of the process: lossy compression and iterative reconstruction for encrypted images. If you want to run the code, please select the main.m file which is present in the source code file. When you right click and give run file button, this window will be displayed. So in this view contains all the user interfaces in order to run the program. When you click on the input image, you can select any image that you want from the folder. Then please click remove noise. This process will remove the unwanted pixels in the image. For denoising, we are using Gaussian filter. This smoothes the image and so that the noises in the images were removed. Then the input image is encrypted and then the input image is compressed. This encryption and the compression process were done in the sender side. So the sender will send the image the sender send the image which is encrypted and compressed to the receiver, so that the receiver initially decompress the image and then decrypt to get the original image. For encryption, we are using permutation based encryption. Same key for the receiver and the sender. So if the receiver knows the original key only, he can decrypt the image. Then compression. For compression, we are using DCT based compression. So this process will be in the receiver side. So the receiver first decompress the image to get the decrypted image, and then using the same DCT based value by applying inverse transform. Then decompression. While decompression, the input image is retrieved with minimum distortion. Then performance analysis is done and the performance are measured. The PSNR value, compression ratio and the bits per pixel values were calculated. Thank you.